So let's practice solving some of these quadratic function problems. Okay, so we're given the quadratic function that has a vertex. We know the vertex coordinate, and we're given a point. Well, if I'm given the vertex, okay, 2, -6, maybe somewhere around here, and a point at 3, -9, I know that my graph must be an upside down parabola, something that looks something like that. Okay, so we have an idea what this graph looks like. Now, since we are given the vertex, the form of the equation that we should try to use is the vertex form or the graphing form. So we're going to start with y equals ax minus 2 squared, don't forget the squared, minus 6. So we're left to solve for a. And this is where the property that any xy pair can be substituted back into the equation. Now, if I substitute this back into the equation, what I end up with is -6 equals -6, which is not wrong, but doesn't actually give us any new information. It's because we're reusing that same information that gave us the function to try to solve for a. So we can't really do that. So we need a new piece of information here, and that's going to be this coordinate. So I'm going to substitute that coordinate into my equation. And the only variable left when I do that is a. And I can actually algebraically solve for a. So when I solve for a, I get a is equal to 1a is equal to, I'm going to add 6 to both sides. So a is equal to -3. Yeah, that makes sense. A is upside down. Okay, and it's a vertical stretch. So my equation then works out to be y equals -3 x minus 2 squared minus 6. Okay, so we're able to come up with two parts of the general form, or sorry, the graphing form using the vertex, and we can find the third part by substituting a. So if I want to find the x coordinate of the vertex of this graph, there's a few different ways I can do this. I can complete the square. Okay, I can factor out the negative. Okay, so what I now have is I have x squared. I have 5x here, 5x here. I need to make this, complete this square, or make this shape square. So I have 5x plus 5, x plus 5. So this must be 25 squares to complete the square. Half the middle squared gives me that last term. Now this is a problem because I now have unbalanced my equation. So I've added in one negative group of 25. So I have to balance that with a positive 25 on the same side of the equation. Once I've done that, I now have my completed square. I've balanced my equation, and I can solve for. Now this is going to give me the x and y coordinate of the vertex. Okay, and in fact, at this point, we probably could predict where the x coordinate of the vertex is going to be. So we could say that x equals, I'm just going to say p is equal to -5. That's what the question's asking for. We also have this Vieta's formula, which finds the middle, okay, and this is a much more efficient way to do it. It's -b over 2a. Well, I know that that middle has something to do with the vertex, and that middle becomes negative of -10 over 2 times a is -1. Okay, so this ends up being equal to -5. Yeah, same solution. Okay, number 1 is much lengthier. It does give us the x and y coordinate of the vertex, so that's the one advantage of completing the square. But if I just want to know the axis of symmetry, really Vieta's formula is probably the more efficient way of doing it. Okay, let's take a look at this one here. We just have some general point. Okay, and we want to find the C value. So if I want to just find one unknown variable part in the equation, I can plug in a coordinate. Okay, so I can go y equals negative 22 is equal to negative 3 squared plus negative 5 times 3 plus c, and there's only one variable left. Okay, so it adds up to 24, negative 24, so I'm going to add 24 to both sides, and I end up with c equals 2. Okay, so I can find the value of c that way.